Electronegativity and polarity. How can we use electronegativity to determine the polarity of a bond or molecule? Objectives. Determine if a bond is polar covalent or nonpolar covalent using electronegativity difference. Determine if a molecule is polar or nonpolar using bonds in a molecule and the shape of the molecule. Polar and nonpolar bonds. Nonpolar covalent bonds, there are equal sharing of electron by the atoms in the bond, while polar covalent bond, there are unequal sharing of electrons by the atoms in the bond. Electronegativity. Using the Lewis electron dot diagrams that show the arrangement of the atoms in a molecule, we can use the electronegativity values of the atoms to determine how the electrons between bonds are shared. Definition. Electronegativity of an atom is its ability to attract shared electrons in a chemical bond. If the electrons are shared equally, the bond is nonpolar, but if they are shared unequally, the bond is polar. This bond information, along with the shape of the molecule, can be used to determine if a molecule is polar or nonpolar. Practice question. Which term represents attraction one atom has for the electrons in a bond with another atom? Electronegativity. Electronegativity difference. Nonpolar and polar bonds. The difference in electronegativity values of two atoms can be used to predict the type of chemical bond. Here we have two hydrogen atoms. For hydrogen atoms, electronegativity difference is 0 because they're identical, while for HCl, the electronegativity difference is 0.9. Note, the smaller electronegativity is always subtracted from the larger, thus the difference is always a positive number. For hydrogen, it means the electrons are shared equally, while for HCl, it means the electrons are not shared equally. There is a symmetrical electron cloud distribution around the hydrogen atoms, while there is an asymmetrical cloud distribution around the H and the Cl. It is not symmetrical. Finally, a covalent bond with identical or similar electronegativity values is a nonpolar covalent bond, while a covalent bond with different electronegativity values is a polar covalent bond. Practice question. Which pair of atoms has the most polar bond? Here is HCl. Because of the electronegativity differences, it has the largest. Therefore, the chlorine will attract the two shared electrons more towards her side. It has an electronegativity difference of 0.9. Dipoles and bond polarity. The polarity of a bond depends on the difference in the electronegativity values of its atoms. For example, here we have HCl. In a polar covalent bond, the shared electrons are attracted to the more electronegative atom, which is chlorine, which makes it partially negative due to the negatively charged electrons. While in the same polar covalent bond, the atom with the low electronegativity, the hydrogen, becomes partially positive due to a lack of electrons around the atom. A bond becomes more polar as the electronegativity difference increases. A polar bond that has a separation of charges is called a dipole. The positive and negative ends are indicated by the lowercase Greek letter delta with a positive or negative sign. For the hydrogen, it's delta positive, and for the chlorine, it would be delta negative. Often, an arrow that points from the positive to the negative charge is used to indicate dipole. Here, the arrow is pointing towards chlorine. Polarity and ionic character. Electronegativity differences ranging from 0.0 to 1.8 and greater. 0.0 to 0.4 would be nonpolar covalent, while 0.5 to 1.7 would be polar covalent, and 1.8 and higher would be ionic. Here we have hydrogen with electronegativity difference of 0.0, which makes it nonpolar, while HCl has an electronegativity of 0.9, which makes it a polar covalent substance. And finally, we can have a partial positive for the hydrogen and a partial negative for chlorine. And for NaCl, we have a electronegativity difference of 2.1, which is clearly higher than 1.8, making it ionic. Besides, it's a metal and a non-metal, which automatically makes it an ionic bond. The sodium lost an electron, which is totally positive, while the chlorine gained an electron, making it totally negative. They are not partial positive or partial negative. Another example for nonpolar covalent would be the carbon-hydrogen bond, a CH bond, with a difference of 0.4. Another example for polar covalent would be an OH bond with a difference of 1.4. As the electronegativity difference increases, the shared electrons are attracted more closely to the more electronegative atom, which increases the polarity of the bond. The greater the electronegativity difference, the greater the ionic character of the bond. Practice question. Which property is used to determine the degree of polarity between two bonded atoms? Electronegativity. Molecular shapes, polar and nonpolar bonds. A symmetrical charge distribution would give rise to a nonpolar covalent bond, even if the bonds within the molecule is polar, while asymmetrical charge distribution would give rise to a polar covalent bond. Molecular shape, symmetrical charge distribution, and nonpolar molecules. In a nonpolar molecule, all the bonds are nonpolar, or the polar bonds cancel each other out. For the first example, molecules such as hydrogen, chlorine, and methane, CH4, are nonpolar because they contain only nonpolar covalent bonds. While a nonpolar molecule can also occur when the polar bonds, the dipoles, cancel each other because they're in a symmetrical arrangement. For example, CO2 is a linear molecule. It contains two equal polar covalent bonds whose dipole point in opposite directions. As a result, the dipoles cancel out, which makes CO2 a nonpolar molecule. Another example is CCl4, carbon tetrachloride, which is a tetrahedral molecule which contains four polar bonds symmetrically arranged around the central atom. As a result, the dipoles cancel out, which makes CCl4 a nonpolar molecule. Molecular shape, asymmetrical charge distribution, and polar molecules. In a polar molecule, one end of the molecule is more negatively charged than the other end. Here we have HCl. The chlorine is more electronegative than the hydrogen, therefore it has a negative charge closer to the chlorine. In molecules with two or more electron groups, the shape determines whether or not the dipoles cancel. For example, water has a bend shape, and since dipoles do not cancel, it is a polar molecule. Another example is NH3, ammonia, which has a tetrahedral electron geometry, but with only 3 bonded atoms, it gives a trigonal pyramidal shape. The individual dipoles do not cancel, which results in a polar molecule. In the molecule of CH3Cl, the carbon-chlorine bond is polar covalent, but the 3 carbon-hydrogen bonds are nonpolar covalent. Since there is only one dipole in the CH3Cl molecule, which does not cancel, it is a polar molecule. Practice question. A molecule must be nonpolar if the molecule has symmetrical charge distribution. Second practice question. Which phrase describes a molecule of CH4 in terms of molecular polarity and distribution of charge? CH4 is a nonpolar molecule with symmetrical charge distribution.